Hello everyone, this is Aravind Seshadri from Roll2Roll Technologies. In the last video, we looked at how to set up the SCU6x controller for multiple web width measurement with a single sensor. We're going to continue on that video. In case you haven't watched that video, go take a look at that, and then this will be a continuation of that. In case you haven't subscribed to our channel, please subscribe and follow us and turn on the notification bell. Today we're going to look at how to get the data from our SCU6x controller, and specifically the multiple slit width measurement application. In a previous video, we looked at how to set up that application with the SCU6x controller. In this video, we're going to look at how to do that from the app we have through the Ethernet interface. Just to recap, we have a sensor here that is ODC960. And we got like 5 different webs there. So we're going to track the width of each lane that we have there. And like I mentioned in the previous video, we looked at how to measure and set some of the parameters from the SCU6x controller. And in this video, we're going to look at how to do the same thing with our app. So if you have the applications where you want to measure the multiple slit width, we would have provided you with an application. And you can open that application and get started. So I'm going to start with that. You can double click on the icon and that will open up this interface. Because we don't have any controller set up the first time, we do have to set that controller for the first time. This dialog will open and you need to know the IP address of the controller. We have additional videos in our library that shows how to find the IP address of the controller in case you don't know that. Also, we need to be in the same network where the controller is set up and where the computer is set up. So we have that condition here. So I'm going to type in the IP address of the device, which is 192.168.1.100. And then that will open up a dashboard. And I'm going to bring it to my screen here so you can see that. So this is the dashboard that opens up. Few things with this dashboard. You can see that it's currently showing what sensor we have connected. Sensor 1 is ODC960 with 7,590 pixels. And then it also gives us some information on the thread count. I mean, it's thread count or web count. It's pretty much the same thing. It has a dashboard that shows a few different things here. Because we're looking at the width measurement application, we're actually not going to be on this screen. We're going to be on a different screen. To look at all the different options that we have, you can go into that screen and pretty much pick the menu that you want to choose. Few other things, you can label this controller. So you can say it is top mandrel or job A or whatever that is that you want to set it up. Usually in a slitter rewinder, you have 2 rewinds, and after slitting, it's split into a duplex, and then you can have the top and the bottom. So you can name that like that. The other thing that you can do is you can set the default download folder location, top mandrel, and then you can select that folder. So anytime we collect the data and we download the data from this app, that's going to go into that folder. If you have another controller and another IP address, you can have an independent folder for that also and set that up so that each one of those controllers have a different place to download that data. This screen that you see here is going to be exactly the same thing that you're going to see on the SCU6x controller. You have the brightness, you have the contrast, and all of those things. If I change any of these parameters, you can see that it's also changing in the SCU6x controller. So the brightness is set to 5 here. If I change this brightness, that's going to show up on this one too. So now the brightness is 22. Essentially, it's just a mirror of what we have there. Everything we did with the SCU6x controller can be done through this app in terms of setting the brightness, contrast, or width specification. I'm going to go to the width config. This is where we spent a lot of time in the previous video on how to set up the samples. Compared to the other screen on the SCU6x, this is just one screen. You got everything you need on the screen. So again, to go through the widths, you can press this icon here, the arrow keys, and it's telling you what web width we have. So width 5, and it's allowing us to scroll through there. The computed width is the actual measurement. When I go to the next one, you see different measurements for each of those. And the raw width is what the sensor is measuring. Then you add that correction and you get the computed width. So that one is also available here on this. So every single width, you can see that the correction is changing like we taught in the previous video. And then each of them has their own sample width. We looked at in the video how to change it in the SCU6x controller. In this case, if you want to change it, it's simpler. You just type in the exact number for that. So I can say 49.35 and it will enter that number. It will enter the value closest to the pixel value in our sensor. It won't be exactly 49.35. In this case, it was 49.3395. Based on the resolution, for most cases, it should be good enough. If you want to change the upper limit, you can do that too. So I can say 1.2 and save. Then it's going to go to the nearest value, which is 1.1906. So you can do that for all of these parameters. And we also looked at alarm and warning limits, the same icon. When you have warning and alarm, you got 4 parameters that you can enter. You can say for the warning, what are the upper limit and the lower limit? And for the alarm, what are the upper limit and lower limit? Usually the warning limits are going to be closer to your nominal width, and then the alarm ones are going to be farther away from the nominal width. So if you press this icon, you can change between either you want to do alarm or warning, or you want to go to a simpler version of upper limit and lower limit, just like what we had in the SCU6x video. And then if you want to set the warning limits, you go on to this icon and press that, and now it shows you the warning limits there. The warning limits are smaller than the alarm limits, and that's what we're seeing here. It makes it easy for us to switch between that and enter those values. This one is the units, so you can switch between millimeters or inches right here. For all of these, you can again enter those nominal widths and upper limit and lower limit, just like we had in the other video. So in order to set up the app for multiple slit width measurement application, you can go into this width configuration screen. As you see, the width configuration screen is pretty similar. On the top, you have the real-time preview of what the sensor is seeing, and it's the same as what you have here, except that you have all the parameters that you can set for your width measurement application. You got the live preview showing the 5 webs I have installed up there. You can use this arrow key to navigate from one web to another web. And that way you can see the actual measurement for each web in real time. There are 2 main things that an operator can do with this particular page. One is to set the nominal width, upper limit, lower limit, alarm, warnings, and all those kind of things, so that you can set this up to constantly monitor the multiple widths and provide a feedback whenever something is unusual or outside your tolerance limit. That can be done by setting the nominal width, upper alarm limit, lower alarm limit, and warning limits, or those kind of things. If you watched some of our previous video, you know what I'm talking about in terms of alarm, warning, upper limit, and lower limit. There are 2 types of setups that you can have. One is a simple setup. You have a nominal width, an upper limit, and a lower limit. As long as the web is between those, you get an all good signal. If the web width is more than the upper limit, then it will trigger a particular digital output. And then if it is below a lower limit, it will create a particular digital output. To set that up, you need to be in upper limit, lower limit mode, and then you can set your values for that. So you can just enter the value. I can say 1.25 for the upper limit, 1.25, and then that provides that value. The value is exactly not 1.25 just because of the fact that it is going to round it to the nearest pixel resolution. So in this case, it's 1.2383, which is close to 1.25 millimeters. And then likewise, you can set this lower limit. So I can set this to minus 1.25 millimeters or 24 millimeters. And that is going to go to the nearest pixel value. With the nominal width and the upper limit and the lower limit, if the web width is right now it's at 49.3354, and if it is more than 1.2 millimeters from this, then you will have the trigger output get triggered for that. So that's the upper limit and lower limit. If you need an extra layer where you want to have a warning and then an alarm, you're going to go into this other mode, which is called as the warning/alarm mode. And when I click on that, there was another button that showed up here, and this is going to set the warning limits as well as the alarm limits. So the warning is below the alarm limits, much closer to the nominal width. To set that, click on this icon. I already have some values there, minus 0.508 and 0.492. If the actual width is between these limits, you get an all good signal. If it goes past the upper warning limit, or if it goes past the lower warning limit, then a warning trigger would come in. And then if it goes past the upper alarm limit or goes below the lower alarm limit, another digital output would trigger. Now, we are using Ethernet here, so you don't need those alarms because you're going to be having the data in there. But if you want the operators to know about this, then you have the ability to set these up and do it. So that's the first functionality with this screen. The second functionality that we have is teaching and calibration. This is essential whenever you have a width measurement tolerance where you need a tolerance within a millimeter. In those cases, we recommend an additional teaching procedure so that you have these set up as good as you can get. The use case for this is in a typical scenario, a slitter rewinder is set. And let's say it's an automotive or a pharmaceutical application. The operator sets the slitter blade positions. He or she pulls the web through the machine. They take a sample for each of this liquid, and that goes into a QC lab. Those samples are measured and approved. Once that is approved, then the operator is going to keep running the machine. And then depending upon the level of data that the end customer needs, there might be a sample taken every new jumbo roll or randomly. With this setup, the measurement can be taken 100% online and inline, and it reduces the time that is needed to keep doing that sampling, where the operator needs to stop the machine and then take the sample, splice and resplice, and then make sure that they can run the machine. So it's a lot of time that is being saved with this type. In order to get the maximum resolution and accuracy, what we do is that when a new job is set up, the operator is going to set the blades, pull the web, and take a sample. And whatever that sample is, we're going to use that and enter that into this app. And from then on, as long as that same pattern is there, you don't ever have to retake a sample because this app would be able to take that data 100% of the time. So how to do that? Let's say you have a sample that you pulled and you have the value for the sample. You're going to enter that sample in there and then press enter or save. Just for this case, I'm going to make a small change there. Let's say 49.425 is actually my sample width. Okay, so that had taken that sample width there. If you observe this, what that teaching does is that we have a raw width that is 49.4189, and then the sample width is essentially 49.4189. It's pretty close. Randomly it just happened that it's pretty close. But then it's going to take that difference between those two and put this in the correction. So I'm going to have this in teach correction, and I'm going to turn off all of these features. And now I'm going to hit the teach button. It says, do you want to teach the width correction? And confirm. It's teaching, and it's providing the difference. So right now the correction is 0.0159, essentially 15 micron. So that's the lowest resolution that we have in our camera. So that's essentially 1 pixel difference. That's what you're seeing there. So you can do that for every single sample. And just to make it simple, you can enter all of these samples in different webs, and you can just have this button teach all enabled and then press teach, and it's going to teach all the samples at the same time. Then each one of them will have its own correction. So just to show you, I'm going to reset all of these. All the corrections are now 0. Now I can do teach all. And then you get all of them a small correction that is being added to every single sample. The use case for this is when you're running a big job, let's say for multiple weeks. The operator sets up the slitter blades, pull the web through, take a sample just like how you would do right now. And then that sample, you're going to enter it in there. From then on, as long as that jumbo roll or the slit pattern doesn't change, they can just keep running this material through the slitter rewinder. You can have 100% online inline measurement without needing to stop and take a sample. That's the advantage. One of the other things we have is what we call a pattern mode. This mode provides an additional level of confidence for the measurement. When you have a particular pattern of slitting that is done with the top and the bottom, you can turn on the pattern teaching mode, and then you can press this button and say teach pattern. And what it's going to do is it's going to not only record the widths, but it also record the edge positions for each of these. So it will keep track of the width change as well as an edge position change for that particular pattern. And then when I say confirm, once this is confirmed, this will automatically turn green. One thing that happens with this is that if I introduced another material in there, you can see that that web in between is being disregarded. It still says that my 5th web is the last web. This is one of the advantages with this pattern teaching mode, is that if there's something wrong with that setup and there's something in the background or any of those, all of these things get disregarded. And likewise, if this web breaks, you will immediately see that it shows that, hey, I'm supposed to see a web there, there's nothing there, and it shows the width computed as 0, and then when the width comes back, you can see that value there. And then likewise, if you move the web, it will keep track of it. As long as the width goes or the position goes way off, then the width goes to 0. It says that, hey, I'm supposed to see a web in that location, but the web has moved. This just means that the blade has moved, and then it will lose that pattern. Again, for the web 4, it does the same thing, but web 3, web 2, and web 1, they're all in the right location. So as soon as this comes back within a certain tolerance, then it picks that up, and likewise it picked it up within that certain tolerance of the initial position. So the pattern teaching mode allows you to have a much more robust measurement in there. So like I mentioned, there are other videos that talks about some of the functionalities with regard to setting the upper limit, lower limit nominal width and how to teach each individual webs. So one of the other things with this app is that now you can take all of these widths and plot them and save them. You can do that by going into this width data page, and right now it is showing all the widths. We have 5 web widths, and all of those widths are shown in a real-time plot, and you can see that right there. And then there's also a table that's showing that actual value of all of these. and you can see that in the bottom table. A general use case would be that you can enter a job number. Let's say I want to say shop order number 43768, whatever you want to do, you can enter that there. And then you can also set the time scale, so 30 seconds or 1 minute or whatever you want to do for that. And you can selectively enable or disable a width. You can say, I just want to see one web width. Okay, that one, width 5. And then you can enable that. Width 1, width 2, 3, 4, and 5. You can see all of those widths there. And then you can download the data. What it will do is download the data to a folder that we had set up initially. So that's what it's downloading it to. When you download the data, it's going to give you a lot of different information. We're downloading the width data, and the name we gave, the top mandrel, goes into the file name. The IP address of the device is also in the file name, and then the job number also comes up there. If we open that, let me show you this data that got opened. You can see that it's got the device name, which is top mandrel, IP address, the job or the sales order number is there, and then each of the widths that we have is there. So width 1, width 2, width 3, and width 6, and all of those widths that we recorded. 5 widths that we have. Got a timestamp. I think it's about 4 times a second it records the data, and you can open this up in any CSV application, Excel or something like that. Like I mentioned, we can selectively save the widths. So you can say that, hey, I just want to see the width 2, width 3. And when you do that, you will get the same thing. Now we have the new data. And if I open the new data, it's just showing you width 2, width 3, and width 4. Those are the width that we selected. It only selectively downloads that data. It's all timestamped. For certain customers, they actually want to label the widths. So especially in lithium-ion battery application, it could be that you want to say this is a trim 1 width, and then trim 2 coating width. And then you can say tab 1 width, coating 2 width. And then you can save the labels. Now all of these are as per what you had labeled, and when you download the data, it will have those labels in there. Just a user-friendly way for you to label these instead of having some abstract width 1, width 2, and width 3, all of those kind of things. And then there's also an option for you to automatically download the data. I can set this up to download the data every minute. Once that time hits a minute, you would have a new set of data downloaded automatically, so that nobody has to manually go in and download this data. You can go make other changes and do other things while waiting to get that data. It'll automatically hit that limit. I will put this to the side, and you should be able to see that as we get a new timestamp. You can also go through this and change the time scale. You can see 4 different time scales: 1, 5, 15, and 30. And likewise, there's also a lot of different time interval options that we have. So you have 1, 15, and all those kind of things. Okay, so we did get another data come in here. So that came in a minute later. So it starts at 57, 49, 57. And then you have the data after that minute comes in. The first time when we download this, it is going to download a lot more data than that. From then on, the second time onwards, it's going to download exactly 1 minute of data. The first time it's going to show you all the data that picked up until then. It started at 3:49:57. At the 1 minute instant, it downloaded all the data. Now we got a new data at 56:37, and this would be exactly 1 minute. So 3:55:37, and then 3:56:37. From now on, it'll be exactly 1 minute data. So you can set this interval to whatever interval that you want, and you'll be able to download the data. We have another option where if you don't want the plot and want to see it as a table, you have an option to see it as a table. So you just click on this and you can change between plot and table view. And then you can also change how many rows you have in the table. You can set more rows if you want to. The table gets updated every 1 second. If you have 30 minutes, it will have the data over that, depending upon your application. If you want to disable a column, you can always press that. It will disable the column. If you want to re-enable the column, you can press that and re-enable the column, just like in the plot view. If I want to disable a row, let's say tab width, disable that, enable that. Just a simple way for a user to collect data from our system. No programming needed. Everything is done automatically by us. So it allows you to install the system, have complete control over the system, and download the data without writing a single line of code. That's essentially it with the app. To set the download folder, you can click on that and select the download folder. Now that we have run this app one time and registered a controller, I'll show you what happens when you reopen the app. I can close this and then I'll reopen the app. When I do that, it's going to create this interface. It says that you've already registered a controller with us before, so it automatically picks that up. Then I can click on that and it opened the app for me. Now, if I go to the, well, obviously you can go to the sensor config, but if I go to the width config, it already has my labels. All my labels are still there. I don't have to worry about relabeling them. My job number is already there. If I need to change the job number, I can change the job number. And the data storage interval is already there. And if I go back to opening that download folder, let me bring that up. While we closed and opened the app and all those things, it's still continuing to collect the data. So 3:58:37, it did another data download, and then I think we're right at the 1 minute mark. Once we hit this 1 minute mark, we should see another data download. So essentially we have a way to keep track of the state. There we go. There was another one that downloaded at 4 minutes. So we have an ability to keep track of the state. Now, if you have another controller, the other controller will have its own state. So you can label all of those things, bottom mandrel, and you can say things like, what is the trim 4, trim 5, coding 4, coding 5, whatever that you want to set, and we'll be able to keep track of that. So essentially, we are making it really simple for our users to be able to interact with our system and do that from any computer. In fact, any computer, you can open this app and run it and be able to connect to the device within your network. So that's a quick overview about the width measurement application with our app. Please subscribe to our channel and make sure to enable notification. We look forward to working with you. If you have any questions, feel free to reach out to us.